Algebra 1, 8.2, we are moving on from just naming polynomials, gathering like terms, to now we are going to multiply polynomials by a monomial. So basically we're starting the fact that we're going to multiply polynomials together. And so the biggest thing you need to do for yourself is remember the distributive property. And so what we're going to do is we got two different problems up here, and as you can see, I've got a 5a squared times the polynomial of a negative 4a squared plus 2a minus 7. Now, this is the funny thing is, this is the second class of this, and I did set it to the same thing to the third out. I said I don't want to see this, because everybody understands distributive property. But I don't want to see this. Why? And then do your work. Why? At the end, I'll see that. But why do I not want to see all three at once? Sloppy. It's not sloppy. It'll make you, it could very well mislead you on what to connect first, second, and third, or what did you already do. Okay? But of course, have someone come to the board, what's the first thing they do? Womp, womp, womp. And then they did the problem. And heck, they even got the numbers mixed up and actually did do it wrong. So be very careful on what we do. The person walking in after the problem's done would see that, because to me that's like showing your work, but I want to see it one at a time. So in this case, I'll do 5a squared times negative 4a squared. Now remember, when you're multiplying two terms together, you can take the coefficients and multiply those, and then you can take the variables and multiply those. You need to know your exponent rules. When you multiply the variables together with the same base, you do what to exponents? Add them. We're past that, guys. I'm not requiring you to write a to the 2 plus 2 anymore. You should know 2 plus 2. 4. So 5 times negative 4 is negative 20a to the 4th. Then I do 5a squared times 2a. 5 times 2 is and a squared times a cubed. 5a squared times negative 7. So negative 35a squared. Are we done? We simplified, aka we'll put it in standard form, gather up like terms. Look at it. It's already got like terms put together. There are no like terms per se. And does it go from highest to lowest power already? Yes. So we are done. We're done. So the biggest thing is, why do we put things in standard form? Back in the last section, when it was just all polynomial, is because now we're multiplying. We're doing simple multiplication right now. It's going to kick up. It's going to be more difficult. You're going to have multiple of these even on the next slide. I want you guys to gather up like terms and put it into an order so that anybody walking into the room can automatically say, or anybody in this room can go and say, hey, for part A, did you get a 4th degree polynomial? Right away, you can look at that and say, yep. Did you get coefficients of negative 20, 10, and negative 35? Yeah. Yeah. All of those things, that if you put it in a special order called standard form, it makes it a lot easier for us to check it amongst each other, check it against the book, all of those things. I'm going to give you guys a couple seconds because I want you guys to do the second problem, and I'll hand off the iPad for someone to do it then. Okay, tell us what you're doing.
Well, first.
Guys, it's recording.
I did. Oh, it's recording.
Watch what's going on.
I multiplied the first terms. 70.
You are being recorded, so what do you say?
Okay. Can I make it smaller? Then I did the next term. Sorry. And then I did the third term. I'm running out of space. the 4th. I'm just gonna have to go on the bottom. And then I combine the like terms, so it would be -18. It's hard to write on this.
Okay. Are we correct? Oh, I'm hearing some no's. Okay, look at our first line first. Let's make sure we did this. Okay, we come walking into the room. We see all the rainbows on there. That's okay, right? Everything's connected correctly. Negative 18d to the 7th power, is that okay? Plus 12d to the 6th. Plus 6d to the 4th. Minus 54d to the 4th. Oh, what should that last one actually be? To the 3rd. And therefore, this last piece, whoops, that just erased all of it. The last piece would not all go together. We end up with plus 6d to the 4th minus 54d to the 3rd. Actually, in this case, nothing actually goes together, does it? There's no like terms. To be like terms, guys, means to have the same variable to the same exponents. Coefficients just means how many of them you have. If you got a whole bunch of fruit in a basket, you would count up all the oranges and you could count up all the bananas. That's fine. They're two different fruits, but they could be in the same basket. It's okay. That's what we did here. We gathered up all the different things that were there. Any questions? Can't leave it this easy, guys. So therefore, we kick it up a notch.
Word problem. That's the hardest part.
Sam.
Equation.
Somehow I'm missing a slide, guys.
So we're
Hold
doing
on.
2 slides.
Here's the slide that we're missing. So, how can we make it a little bit more difficult but realize it's not? It's just take both of the type of problems in A and B from the last page and then add them or subtract them. So this is really no different. The biggest thing you guys need to do is you need to sit back and ask yourself, do I need the parentheses, yes or no? And to take a look at both of these groups. They both have something in front of the parentheses, which means you do need them, which means I need to get rid of them by distributing. Right? And so,
Is that -1 then?
what do you mean? That's a negative x. A negative 1x, right. So, take the 3. 3 times 5x squared is 15x squared. 3 times 2x, and 3 times -4, -12.
Boom.
Now, the second group is a negative x. I will use it as a negative x. Negative x times a positive 7x squared. Negative 7x cubed. Because x times x squared is x cubed. Negative x times 2x. Negative 2x squared. Negative negative makes a 3x. And now, are we in standard form? Highest to lowest powers?
No.
Combined like terms? No, we need to make it happen. What's the highest exponent? The highest exponent is a 7x cubed. So, how many of those do I got?
1.
So it's a negative 7x cubed. Next, power is x squared. There's 1 and there's 1. 15 of them minus 2 of them.
13.
It's 13 of them. X is 6 of them plus 3 of them gives me 9x. Minus 12. Done. And there's our answer, guys. It's just taking the two steps, break them up, and gather like terms. Make sure you're in standard form. Guys, what's the degree of this polynomial? 3. What's the leading term? Negative 7x cubed. What's the leading coefficient? Negative 7. And what's the constant? Negative 12. Boom. Adding 8.1 stuff into 8.2. Pretty cool, right? Next problem. I'll give you guys a couple seconds to work on that one. That one's an interesting problem. Okay, so what am I going to do with this one, guys? Distribute the 15t. So, Nick, what is it? 15t times 10, y to the cubed, t to the fifth is 150. Yes? Keep going. y3. T? 6. And then all the way across, plus, what's 15 times 5?
75.
75. Y t squared. Okay. Negative 2y times y t squared becomes a negative 2 t squared. Not plus. Minus 8 y cubed. Are we done? Now, question. Is there really a standard form for this one?
No.
Not necessarily. So if this is the case, guys, I wouldn't mess with the order of things, but I definitely would look through here and say, can I put any of these together?
Do those two. Yes.
And which ones can we put together? Will?
75y squared t squared.
Yeah, the 75y squared t squared minus 2y squared t squared. Because these two things are exactly the same thing. You guys, they're the same thing even if I say t squared y squared. Because multiplication is associative, right? Or a commutative. So, therefore, the answer is 150 y cubed t6 73 minus 8y cubed. Done. Next up is a word problem that uses the fact that there's going to be multiplication, guys.
I thought this said bananas.
Yeah, that's what I thought too.
Okay, Sam is making triangular bandanas for the dogs and cats in her pet club. The base of the bandana is the length of the collar plus 4 inches added to each end to tie it on. The height is 1/2 of the collar length. Twofold. If Sam's dog has a collar length of 12 inches, how much fabric does she need in square inches? And part 2 says, well, what if she wants to make one for her friend's cat with a 6-inch collar? How much fabric in square inches does she need? Then, the question is, what happens, because this has only got 2 components to it. I think most of us could probably add and subtract to 12 and to 6 to make this work. But what happens, guys, if I had 100 pets that I need to make this for? Does any... The question is, guys, do you want to sit there and with every collar length figuring out, adding 4 inches to both sides, taking half of it, and then multiply? Or do you want to create an equation that you can figure this out? What are we actually finding here? Square inches. What is that?
Distance of radius. length, the width.
It's recording, guys, yes. Square inches represents what? What is measured in square inches? Area. Guys, okay. Area. If area of what? The bandana. But the bandana happens to be a So we're going to find the area of a triangle, and what is that, please? 1/2 base times height. So guys, let's think of this. I'm going to take this and build a formula for the area so I know exactly how many square inches, and everything seems to be based off of the dog or pet's what? Collar length. So, could I base everything off of C? As in 1/2, not that big of a deal. 1/2's 1/2. But what's the base? It's the collar plus, not 4. It's 8 because there's 4 on each end. And then the height is not height, it's 1/2 of C. You guys now have a formula that we can plug in for C, and we would have an answer. Now, there's options. I can take the 1/2, bring it in. I can take the 1/2 C, bring that in, creating something in standard form, or we can leave it just the way it is. And so you get 1/2. Her dog has a collar length of 12, so plus 8. Times 1/2 of 12, which is 1/2 times 20 times 6. Half of 20?
10.
Times 6? 60 inches squared. Next one, her friend's cat, which has 1/2, 6 plus 8 times 1/2 of 6, which is 1/2 of 14 times 3. And 1/2 of 14 times 3? 21 inches squared. Easier if you have a formula, because now I can ask you, what if they have a 7-inch collar? What happens if they have a 25-inch collar? Because it's an elephant. I don't know. So a 3-foot collar. It's a giraffe. I don't know. And the last thing we're going to talk about is what happens if we have an equation that has variables on both sides, which we've done before, but now we got groups, some with coefficients and some without coefficients. What it comes down to is, what are you going to do with your coefficients? Distribute them. Basically comes down to the same question. Self, do I need the parentheses or not? First group, do you need the parentheses? Yes, so distribute. The second set of parentheses, do you need them? No, just get rid of them. Third set. Yeah, distribute again. I think gather up like terms. Once you gathered up like terms, that's when we start to solve. Bring everything to one side. 2x times x. 2x times x.
2x times x.
2x squared. 2x times 4.
4x.
No. 8x plus 7. You guys told me I do not need these parentheses, so I'll take them away. 2x times x.
2x squared.
2x times 1.
2x.
Plus 12. Everybody okay with that first step? Second step, gather like terms. Left-hand side, do I need to do anything over here? No. Look, it's already in standard form, gathered up. That is definitely not gathered up and definitely not in standard form. So what's the highest exponent? 2x squared. So I'll start off with a 2x squared. Then I'm going to move to the x's, which I'll put a double line. 2x plus an x is 3x. And 8 plus 12 is 20. Now I got to start bringing things from one side to the other. Hey, wait a minute. They both have a 2x squared. So it doesn't matter which way I go. If I subtract a 2x squared from both sides, they are gone. So I'm left with 8x plus 7 equals 3x plus 20. Which way do I want to go with my x's now? Left or right? We go left. Why? We don't get a negative number. Always move your smallest one. It betters the chances of dealing with positive numbers. Would it be wrong to go the other way, though? No. So subtract 3x, and if I'm going to subtract 3x, that means I'm also going to subtract 7. Would you guys agree with that to get the number to the other side? 5x equals 13. Divide both sides by 5. And so x is equal to 13/5. If you want to know if you're doing things right, you will plug this back in. Where? In the very original problem. Because you don't know if you made a mistake in your distribution or someplace else along the way. Check it here. It should work. You don't have to, but if you have time, you always should be checking your work, making sure you did it right.
Does that get you a 7?
Checking your work will get you to the 7s. Homework, worksheet 8.2. Have a great day. Actually, I forgot to say it to the people who left, so you might want to inform them. Odds.
Oh,
yeah.
Because guys, it's odds because the answers are on the back. And 2, but you have to do both word problems.
Odds, what? Hey,